Hi folks, in this video segment I will show you how to take an assembly made out of 4 parts. It can be any number of parts, but I'm assuming it's 4, and combine all of these parts into a single part. In other words, convert your assembly into a single part and then do FEA analysis on that single part. The reason that you may want to do that, although the response may not be the same, is that it could be that you have an assembly and you want to do a very quick and basic analysis on it in finite elements, and you want to avoid making all the connections that are needed to model the interaction between the parts. For example, the fasten, the contact, the rigid, etc. All right, the process is very simple and it sounds simple. However, there are some subtle steps that unless you follow, you would not succeed in getting it to work. What you see here right in front of you, there are 4 parts that are in that assembly as shown, and I'm assuming that all the parts are made of the same material. Now, needless to say that if the parts are not made of the same material, it's just meaningless trying to combine them into a single part, because then what are you going to assign to that as material property? So I assume I applied steel on the entire assembly. Okay, dimensions are not important because I'm showing you here the steps in order to achieve your objective. All right, the first thing that you want to do is you want to convert these into a single cat part. And if you look under the tool, when you're in the assembly workbench, you see here it says generate cat part from product. You click on it, and then it says, okay, what's the name of that cat part that you want to create? Well, we can select this thing on the top, so it basically inherits the name. And in the event that you have bodies inside of these parts and you want to merge them, then you check this box. I don't have any bodies, and therefore I say okay. All right, so what happens here is this is a single part. However, if you look at it, these dumb solids associated with each part have been created, and you have to do Boolean operation in order to combine all of these into a single dumb solid. So I can use the add Boolean operation right here, and you have to patiently do this thing. So you add, for example, this guy to the top one, and then you say okay, and then again you do this guy to the top one, say okay. Once again you select this and add it to your part body. So you can see that basically I'm stuck with this single part body. Okay, now what we need to do, first of all, let me save this thing. File, save management. This is the one that we created right there. Save as. I'll use the same name. Okay. What you next have to do is to convert this thing into a step file. So you go to File, Save Management, select the file that you just created and saved right there. This is the product one, all cat part, and you save as. Change the format to step, STP. Change the save as type step, and give it a name that you recognize. I'll say my dumb solid. Okay, and I'm going to put it in that same folder. All right, just to show that everything is working, so I'm going to close this. I'm going to close that. Basically, I don't have anything open, so I start CATIA. I say File, File, Open. Let me take that my dumb solid step file, and we say Okay, there we are. All right. Now, notice that this whole thing has resulted with a single part, and this is the dump solid. This means that there is no history associated with it. That's why we call it dump solid. Okay, now what we're going to do is we're going to go to analysis and simulation, generative structure analysis. The first thing you realize is that it says material is not properly defined. As a matter of fact, that material that I put at the assembly level is not inherited. That's why it says, I don't know what the material is. We say, okay. And obviously we're doing a static analysis. What has happened is that there's a single mesh where this thing is being discretized. So you can look at it, right click, and notice that this is a part that is meshed, because otherwise if this was an assembly, there would be 4, mesh sizes each for each part. Now, then you look at it, you see that the 1D property is an exclamation mark here, because it really doesn't know what the property is. Okay, it didn't carry over. The first thing I'm going to do is I'm going to delete this. Okay, then I'm going to create a user-defined material. Notice that there's no material here. Here is the user-defined material right there under Model Manager. You click on it, metal, you scroll down and you select steel and you say OK. So what happens is that a user-defined material has been created here, which is the properties of steel. And then you go to again Model Manager and the 3D property. Remember I deleted it, now I have to create it again. And it says, okay, what is the support? The support is that mesh, okay, the entire discretization. And it is a user-defined material. So I check and I go from the tree, I go and select this material. That was the properties of steel. And I say, okay. All right, now let's do the analysis. So I'm going to deactivate my mesh. Let's hypothetically say the bottom of this is clamped, so I'm going to clamp that. Where's the clamp? There's the clamp. Okay. And let's say that I apply some kind of pressure on this face. Okay. So the pressure is right here on that face. Okay, 50 units. These are all meaningless because I don't even know what my dimensions are. And then you where is that? You run it, compute. Say OK. Notice that this is a single part. There is no need for interactions to be defined. And then you can look at, for example, the displacement right there. Let's change the rendering. Right, and this is the deflection, and you can look at the stress. Needless to say that the stress is biggest here because this is a flimsy part. So that takes care of it. So remember, what you need to do is first you have to take your assembly, convert it into a single part using the user-defined, using tools, and then the line in the menu says converted to a part. And then don't forget to add them up, because if you don't add them up, once you go through all these steps, once again you open up the step file, you're going to see 4 different meshes, which basically means that they came as an assembly. You still have to create the interaction between them. Okay, good luck.